Welcome to Z. Today, we're embarking on an exciting journey to explore Mercury, the smallest planet in our solar system and one of the most enigmatic. Despite its petite size, Mercury is bursting with unique features and intriguing characteristics that make it a captivating object of study. From its extreme temperature swings to its unusual geological features, Mercury offers valuable insights into the history of our solar system. So, let's delve deep into this fascinating planet and uncover what makes it truly unique. To start our exploration, let's cover some fundamental characteristics of Mercury. This tiny planet is only slightly larger than our Moon, with a diameter of about 3,032 kilometers, making it the smallest planet in the solar system. Mercury is the closest planet to the Sun, with an average distance of about 58 million kilometers. Mercury's orbit is notably rapid. It completes a full orbit around the Sun in just 88 Earth days. However, due to its slow rotation period, which takes about 59 Earth days, a single day on Mercury, the duration of one full rotation on its axis, is significantly longer than its year. This unique relationship between its rotation and orbital period leads to some fascinating phenomena, such as the fact that during certain times of the year, Mercury experiences a day-night cycle where the Sun appears to rise, pause, and set twice. This is a result of Mercury's elliptical orbit and its axial tilt. One of Mercury's most striking features is its extreme temperature fluctuations. Because of its proximity to the Sun, daytime temperatures can soar to a blistering 430 degrees Celsius, 800 degrees Fahrenheit, while nighttime temperatures can plunge to a bone-chilling minus 180 degrees Celsius, minus 290 degrees Fahrenheit. This dramatic temperature difference can be attributed to Mercury's very thin atmosphere, which is incapable of retaining heat. Unlike Earth, which has a dense atmosphere that helps moderate temperature, Mercury's atmosphere, composed primarily of oxygen, sodium, hydrogen, helium, and potassium, offers little protection against the Sun's rays. Interestingly, the temperature variations on Mercury also lead to some unique challenges for potential future exploration. Engineers and scientists must develop materials and technologies that can withstand both the extreme heat during the day and the frigid cold at night, making lander and rover designs particularly complex. Let's shift our focus to Mercury's surface features, which tell a captivating story about the planet's geological history. The landscape is characterized by a multitude of craters, cliffs, and plains that reflect a turbulent past. Mercury is home to some of the largest impact craters in the solar system. One of the most notable examples is the Caloris Basin, a colossal impact crater measuring about 1,550 kilometers, 960 miles, in diameter. Formed by a massive collision during the early solar system, the Caloris Basin is surrounded by a ring of mountains that formed from the energy of the impact. In addition to craters, Mercury features unique geological formations known as lobate scarps. These cliff-like structures were created as the planet cooled and contracted over billions of years. Some lobate scarps extend for hundreds of kilometers and rise several kilometers high, showcasing Mercury's geological activity and history. Interestingly, MESSENGER data has revealed signs of volcanic activity on Mercury. The presence of smooth plains, known as volcanic plains, suggests that Mercury was once geologically active and may have experienced volcanic eruptions in its past. These findings challenge the perception of Mercury as a geologically dead planet and open new avenues for research. Another intriguing aspect of Mercury is its magnetic field. Despite being the smallest planet, Mercury possesses a significant magnetic field. about 1% the strength of Earth's. This is surprising given Mercury's size and slow rotation. Scientists believe that Mercury has a large iron core that makes up about 75% of the planet's radius. This core is thought to be partially liquid, which generates the magnetic field through a dynamo effect, similar to that of Earth. Understanding Mercury's magnetic field provides crucial insights into its internal structure and the dynamics of its core. The existence of a magnetic field also indicates that Mercury interacts with solar wind, the stream of charged particles emitted by the Sun. This interaction creates a unique environment around the planet, influencing its surface and atmospheric conditions. Until recently, our understanding of Mercury was limited. However, NASA's MESSENGER spacecraft, launched in 2004 and arriving at Mercury in 2011, significantly advanced our knowledge of this enigmatic planet. MESSENGER provided detailed images and data regarding Mercury's surface, composition, and magnetic field. Among its many discoveries was the confirmation of water ice in permanently shadowed craters at the poles. These craters, shielded from sunlight, provide a cold trap where water ice can exist, revealing that even in such an inhospitable environment, water can find a refuge. Furthermore, MESSENGER identified a variety of minerals on the surface, including magnesium and sulfur, contributing to our understanding of the planet's geological processes. As we look to the future, missions like the BepiColombo mission, a joint effort by the European Space Agency and the Japan Aerospace Exploration Agency, aim to continue exploring Mercury. Scheduled to launch in 2023, BepiColombo will conduct detailed studies of Mercury's surface, geology, and magnetic field, further enriching our understanding of this unique world. Mercury's unique characteristics also place it in a special context within our solar system. Its proximity to the Sun and lack of a significant atmosphere mean it is constantly bombarded by solar radiation. This makes Mercury an excellent laboratory for studying solar phenomena. Mercury's extreme conditions also challenge our understanding of planetary atmospheres and surface processes. By studying this planet, scientists can gain insights into the early solar system and the formation of terrestrial planets. Moreover, understanding Mercury can provide crucial information about exoplanets that orbit close to their stars. Many of these exoplanets likely experience similar extreme conditions, making Mercury an important analog for studying their atmospheres and potential habitability. Beyond its scientific significance, Mercury also inspires cultural and philosophical reflections. Its status as the smallest planet evokes thoughts about size, scale, and significance. In a universe so vast, what does it mean to be small? Mercury challenges our perceptions and invites us to consider the beauty and complexity of even the smallest celestial bodies. Additionally, the mythological associations with Mercury, named after the Roman messenger god, remind us of humanity's enduring fascination with the cosmos. As we explore planets like Mercury, we engage with the larger narrative of exploration, curiosity, and the quest for knowledge that defines humanity. Mercury, the smallest planet in our solar system, is a world of extremes and curiosities. From its intense temperature fluctuations to its unique geological features, Mercury continually challenges and enriches our understanding of planetary science. As we continue to explore this remarkable planet, we not only uncover its secrets, but also enhance our knowledge of the solar system as a whole. The discoveries we make about Mercury may hold the keys to understanding the processes that govern planetary formation and evolution. Thank you for joining me on this journey through the unique features of Mercury. Until next time, Keep looking to the stars and contemplating the mysteries they hold.